Hi and Assalamualaikum. In this video, we will present about applications in wave motion and sounds.
Assalamualaikum and hi, my name is Nurdina Ayuni. My metric number is 2022870522. Before we get started, let's go through sound wave. What is sound wave? A sound wave is the pattern of disturbance caused by the movement of energy traveling through a medium, such as air, water, or any other liquid or solid matter, as it propagates away from the source of the sound. Sound waves are created by object vibrations and produce pressure wave. For example, a ringing cell phone. The pressure wave disturbs the particles in the surrounding medium, and those particles disturb others next to them, and so on. The pattern of the disturbance creates outward movement in a wave pattern, like seawater in the ocean. The wave carries the sound energy through the medium, usually in all directions and less intensely as it moves farther from the source.
I am Zulaika binti Muhammad Zaharini. My student ID is 2022609658. Now, I will present to you about sound wave in medical imaging. Sound waves are vibrations that travel through a medium such as air or tissue. This vibration can be used to create and visualize image of inside of the body without surgery. Imaging with this wave can provide very useful and very different information about the tissue in the body being examined. Next, application in ultrasound imaging. First, ultrasound can be used for monitoring a pregnancy. Ultrasound can confirm that you are pregnant. Check if you are pregnant with more than one fetus. It also can estimate how long you have been pregnant and the gestational age of the fetus. It also can check the fetal growth and position and see the fetal movement and heart rate. Next, ultrasound can be used for abdominal imaging. It can detect abnormalities in the liver, gallbladder, kidney, pancreas, and spleen. Also, ultrasound can be used for muscle and tendon injuries. Ultrasound can help to diagnose and monitor muscle and tendon tears and other injuries. Next, droplet ultrasound. Droplet ultrasound uses the droplet effect to measure blood flow in vessel. The droplet effect is the change in frequency of a wave as the source or observer move. It also can measure the speed of the blood flow and direction of the movement. Next, echocardiography. Ultrasound can detect abnormalities in the heart wave such as stenosis or regurgitation. Next, it can help identify birth defect of the heart. Lastly, it can assess the function of the heart and help determine the severity of heart failure. Benefit and challenge of ultrasound. First benefit is use non-ionizing sound wave. Second, ultrasound examination is less expensive to perform than CT scan or MRI. Lastly is a real-time imaging. First challenge is difficult to penetrate deep layer in body human. Second, it's difficult to obtain ultrasound with high diagnosis quality. Lastly, some ultrasound exams may be limited by abnormally large body habitus. future development in ultrasound technology. First, 3D and 4D image, more detailed and realistic image for better diagnosis and treatment planning. Second, AI-powered analysis, automated image analysis and interpretation for faster or more accurate diagnosis. Lastly, use of nano ultrasound. It can developing ultrasound that are more target and precise for specific application.
Hi, I am Nur Azrin Arnisham Azman. My metric number is 2022481544. Moving on to the second application, which is sonar. So what is sonar? Sonar is an acronym that stands for Sound Navigation and Ranging. Sonar is a technology that uses sound waves to detect and locate objects underwater. For example, maritime navigation to exploring the depth of the ocean. There are two types of sonar, which are active sonar and passive sonar. Active sonar transducers emit an acoustic signal or pulse of sound into the water. If an object is in the path of the sound pulse, the sound bounces off the object and returns an echo to the sonar transducer. The second one is passive sonar. Passive sonar is used to detect noise from marine objects such as submarines or ships and marine animals like whales. Passive sonar cannot measure the range of an object unless it is used in conjunction with other passive listening devices. Sonar maximum frequency range 1 GHz. Sonar is used because sound waves travel through water much better than radar or light. Sonar works by calculating the echoes. Once the speed of sound in water and the time it takes for signal to return is identified, the object's distance can be determined. So how does sonar works? Principle of sonar, it uses echoes to determine the sea depth and locating the presence of objects underwater. Sonar consists of a transmitter and detector and is installed in a ship or a boat. The transmitter in sonar produces and transmits powerful ultrasonic waves. The ultrasonic waves travel through the water, and after striking the target, the beam is reflected from the seabed and is received by an underwater detector which is mounted on the ship. The detector then converts the waves into electrical signals which are properly interpreted. The time travel between transmission and the reception of the signal is also noted. There are many importance of sonar. For example, underwater navigation. Sonar helping ships and submarines navigate safely beneath the water surface. Next, search and rescue. Sonar invaluable in search and rescue operations, especially in locating sunken ships or downed aircraft and even a missing persons. Next, marine exploration. Sonar helps researchers map the ocean floor, identify geological features like underwater volcanoes and trenches, and study marine life. The last one is commercial fishing. Commercial fishermen rely on sonar to locate schools of fish and assess their size and density. This information helps them optimizing fishing operation, reduce bycatch, and make sustainable harvesting decisions. Moving on to the last part, which is challenges and future development of sonar. Marine life such as fish and other underwater organisms may be sensitive to ultrasound waves. Low resolution of image and significant noise interference due to scattering of ultrasound wave. The poor placement of ultrasound transducer may cause the ultrasound coverage is incomplete or fails to capture information. For the future development of sonar, formation of 3D that allows more details underwater view, synthetic aperture (SAS), which allows for much higher resolution image than traditional solar by combining the different acoustic bands. The last one is dolphin inspired sonar.
Assalam and hi, my name is Nurdina Ayuni. My metric number is 2022870522. Today I will be presenting about radio wave communication system. First one is transmitter. The processing and encoding of the signal to be transmitted for communication is done using a transmitter. Two distinct types of signal are transmitted known as analog and digital signals. Both have a distinctive character pattern that can be converted to the other. Second one is communication channel. The medium used for the transference of the signals from the transmitter to the receiver without distorting it is called as communication channel. And the last one is receiver. The receiver receives the signal and decodes it into an understandable sound wave. Next is wave motion and sound in mobile phones. Not only do radio waves travel long distances, but they are also good at penetrating solid materials such as walls. This makes the radio wave ideal for carrying cellular and telephone signals. Cellular phones have built-in receivers and transmitters. Transmitters work by converting audio signals into electromagnetic radio waves. The radio wave then travel long distances and are routed and relayed via cellular stations and towers until it reaches the phone of the recipient. The receiver then decodes the signal back into audio, which is played back to the recipient. Another advantage of radio wave in this application is that they travel at the speed of electromagnetic wave in free space, which is million meters per second. This means that communication can happen almost instantaneously with very little delay. Next is application of radio wave in radar. Radar is an acronym that stands for radio detection and ringing. The principle behind radar is quite similar to sonar, but electromagnetic waves are used rather than sound wave. Sound waves don't travel significantly fast enough in air to be useful in detecting obstacles. Therefore, the wave turn into the electromagnetic spectrum, which can also undergo the wave motion property of reflection to detect objects that are in the sky. Radio waves are transmitted through the air via large antennas, reflect when they strike an obstacle, and return via the same medium to the receiver. We can then use the time it takes for the radio wave to return to determine the distance to the object. The wave travels a total distance of 2r in the round trip to the object and back in time t. Radar signal can penetrate insulators. Materials that are considered insulators such as rubber and plastic do not hinder radar signals from collecting data. The signals will penetrate the materials and capture the necessary data required.
In conclusion, there are many benefits of ultrasound because it can be used in various industries. In medical, it can be used to detect various diseases or organs in the human body without need to do a surgery. Next, ultrasound is used in sonar, which is a technology that uses sound wave to detect objects underwater, useful for underwater navigation and more. Lastly, ultrasound can be applied in communication because it can travel at the speed of electromagnetic wave in free space.